These are notes for Melham's Math 60 for Monday, April the 27th, section 9.4, page 798. We're now doing logarithms. And to think of logarithms, it's best to just know what they stand for. When you see an equation like y equals log base b of x, this b is sunken down next to the g, that's called the base. It means the same thing as b to the y power equals x. The interpretation is the number that's down here is called the base, which kind of makes sense. Base of a building is furthest down. You go across the equal sign for the exponent, and you come back in for the result. And here are some examples of rewriting logs as exponential statements. So the first few problems just ask you to write the log as an exponential. Log base 3 of 81 equals 4. That's the way you read it. Again, the base is sunken down next to the g. Means the same thing as 3 to the 4th power equals 81. The green is what I introduced. The original problem didn't have the green, but you start with the base, which is 3. You go on the other side of the equal sign for the exponent, 4. You come back in for the result. So 3 to the 4th equals 81. Here's another one like that. Log base 5 of radical 5 equals a half. Write it without the word log. So first you start with the base. So the base is 5. It's the thing that's sunken down. You go across the equal sign for the exponent. So the exponent is a half. And you come back in for the result, which is radical 5. So 5 to the 1/2 is equal to the square root of 5. So one more example written like this. T equals log base b of t1. So you always start with the base. The base in this case is b. You go across the equal sign. Now this time to go across the equal sign, you have to go to the left. The other instances you have to go to the right. But wherever the equal sign is, you go across the equal sign for the exponent, b to the t, and you come back for the result, which is t1. Okay, starting with problem 39, they ask you to go the other way. They start off with an exponential equation, like 8 squared equals 64. Then how do you write it as a log? So to write it as a log, first you write down the word log, L-O-G. And my advice is always to start with the base. So which of these three numbers, 8, 2, and 64, is considered the base? Well, it's 8. So 8 will be sunken down. So you got the 8 out of the way. So all you have to do is worry about where do I put the 2 and the 64. But if you recall what we just said, the 2 goes across the equal sign. So I put an equal sign, put the 2 over here, and then come back in for the result of 64. And a quick double check of what we did over here, 8 squared equals 64. 43, 1/2 to the negative 5 equals 32. Rewrite it as a log. So to write it as a log, first you write the word log, and then just figure out where these 1, 2, 3 elements go. I always say start with the base. The base is a half. So the half is sunken down next to the g, log base 1/2. Now you just have to figure out where does the negative 5 go, where does the 32 go. So the exponent, negative 5, the rule is the exponent goes on the other side of the equal sign. So you put the negative 5 here and you come back in for the result, which is 32. And a quick double check, 1/2 to the negative 5 is equal to 32, which is what we have over here. Okay, one more example of that, 49. 7 raised to the 4.3 equals b plus 1. Write it as a log. So if you're going to write it as a log, first write the word log. Start with the base. The base is 7, so that's sunken down next to the g, 7. Okay, and then on the other side of the equal sign is the exponent. The exponent is 4.3, so that stands way over here. Come back in for the result, which is b plus 1. And notice in this case you have to put parentheses b plus 1, because if you don't put parentheses, the interpretation is log base 7 of b, and then add 1, which is not the same thing, so this one should have parentheses. Okay, then starting with 51, we're solving equations that have logs involving an x. So log base x of 81 equals 2. Unscramble it is what I often say. That's not an official word, but I like it. So start with the base, which is x. Exponent is 2. Come back in for 81. So x squared equals 81, which means x equals 9. Okay, and a side note, if you do the square root property, you would normally say plus or minus 9. But for logarithms, the base for a logarithm is always positive, so we don't have to worry about the negative 9. The answer is just 9. Okay, number 53, log base 8 of x equals 2. Unscramble it. Exponent is 2. The base is 8. 8 squared equals x, so that means x is equal to 64. 55, log base 5 of 125 is equal to x. So notice for these problems, they're changing the location of x. Here x is the base, Here x is on the inside after the base, and on this problem x is all by itself. So in any case, just unscramble it. 5 raised to the x power equals 125. So what exponent do I have to put up here to make it a true statement? Well, we know it's 3 because 5 times 5 times 5 is 125. 63 is a little bit harder. So log base 27 of 9, call it x. Unscramble it. 27 raised to the x is equal to 9. Now, this doesn't look like anything that's recognizable, but we can make it recognizable if we change both of these to base 3. I can write that as base 3. I can write that as base 3. So 27 we know is 3 cubed. So I write 3 cubed to the x. 9 is 3 squared. And now we have a property that says if I have a power of another power, I can multiply these powers. So 3 to the 3x equals 3 squared. And now that these two bases are the same, I just equate the exponents. So 3 raised to something equals 3 raised to something. These two somethings have to be equal. So 3x equals 2 means x equals 2/3 is my answer. 69, log base x of 1 over 64 is equal to -3. Unscramble it, base, exponent, result. So x at a -3 equals 1 over 64. Then you might recall x at a -3 means 1 over x cubed. So 1 over x cubed equals 1 over 64. I'll do the cross multiply rule, which says that times that equals that times that. Well, x cubed times 1 is just x cubed, and 1 times 64 is just 64. So what number cubed gives me 64? That answer is 4. Okay, 75. The original problem was log base 2 of 8. So in green here I have stuff that I wrote in. The problem just says log base 2 of 8, but I will put in equals x so I can start the unscrambling business. So log base 2 of 8 equals x, unscrambled, 2 raised to the x equals 8. And now you say, what exponent do I put up there to make it a true statement? That's 3. 2 to the 3rd power, 2 cubed. 2 times 2 times 2 is equal to 8. 79 requires something that's an understanding. This one just said log of a million. If it just says log of a million, if there's no base, the base is understood to be 10. So one thing that you want to keep in mind, if no base is given, the understanding is that it is base number 10, and that happens to be true on most calculators. So on a typical calculator, if it just says log LOG, that means base 10. So there's an understood 10 here, and so green is the stuff that I put in extra, and I call it x. Then I unscramble. 10 to the x equals a million, and so what exponent do I put up here? We know that that's equal to 6. And in fact, a shortcut is to say that you have 6 zeros, so you know that there has to be a 6 there. Okay, here's 83. Log base a half of 1 over 32 is equal to x. Again, the green wasn't there, I put it in, so call it equals x, unscramble it. 1/2 to the x equals 1 over 32. I can split this up into 1 over x on top, but 1 raised to anything is just 1, and the bottom is 2 to the x. And now that problem kind of looks like this one over here, cross multiply. If you multiply by 1, you don't do anything, just leave it alone. So 2 to the x equals 32, which means x is equal to 5, because 2 to the 5th power, 2 times 2 times 2 times 2 times 2 is equal to 32. Okay, now 87 and 89, they're asking you to find logs of certain numbers. These are log base 10. So on my particular calculator, I'll just hit log of whatever number I want. So if they want the log of 3.25, you simply just punch it in your calculator. There's really no work. Just wanted to see if you know how to punch this in your calculator. So I hit log of 3.25, and in the homework set they asked you to round to the nearest fourth decimal place, so that's 0.5119 for that one. Just punch it in the calculator. And then here's another one, 89, log of 0.00467. So again, you can just hit log, L-O-G, of 0.00467, and on a calculator I get negative 2.3307. So that's all you have to do for that. A quick word of caution, depending on what kind of calculator you have, you might have to hit it in backwards. In other words, you might have to hit 3.25 log or 0.00467 log. Just experiment with your calculator. Either type it just as is, or you might have to type it backwards. Either way. Okay, now problem 91 says the log of x equals 3.7813. again, you pretend that there's a 10 there. So it only said log x, so I make the assumption that the base is 10. So unscramble it, x to the 3.7813 is equal to x, or 10 to the 3.7813 is equal to x. Then I just punch it in a calculator. By the way, on my calculator, to get an exponent, it's going to be this one, the up caret. Some calculators, you need something that says y to the x, or maybe x to the y. Either of those might work. And in any event, this one comes out to be 6,043.6597 on the calculator. And here's 95, similar thing. So the problem just says log x. I put in the 10 in green because that's what it means. And I unscramble it. 10 raised to the negative 0.5 is equal to x. So I just punch that in my calculator, and I get 0.3162. Finally, for 99 and 101, they don't actually ask you to graph it, but they just want to ask, is the function increasing or decreasing? Does it go up or down? And a simple way to do that is to just plot 2 points. We're not that comfortable with logs, so how about write it without the logs? So I call this y. Remember, f of x is equal to y. Y equals log base 3 of x. Unscramble it. 3 to the y equals x. And written like so, it's actually easier to plug in values of y than it is to plug in values of x. So I plug in y is 0. So put it 0 for y. 3 to the 0 is 1. So I have 1, 0. And I decided to plug in 1 for y, and that gives me 3. So I have 2 points, 1, 0, 3, 1. 1, 0, and 3, 1 means the graph goes something like that, which means it's an increasing function. And finally, 101, same thing. Is it increasing or decreasing? Y equals log base a half of x. Unscramble it. Base is a half. Exponent is y. The result is x. So 1/2 raised to the y equals x. So once again, don't plug in for x, plug in for y. So I plug in y is 0. Well, we know anything that's 0 is 1, so x is 1. And if I plug in y is 1, 1/2 to the 1 is 1/2. So I have 1, 0, and 1/2 comma 1. Here's 1, 0, 1/2, 1 is something like that. So if we were to plot more points, it looks like this, and this is what's considered a decreasing graph. All right, so this is some work on logarithms. This is Melham's Math 60 for Monday, April the 27th, section 9.4, page 798.